Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE Computer Science and Data Science. So in last video we have discussed system of linear equation, mainly non-homogeneous. So we have discussed that we have three different types of solution in non-homogeneous system of linear equation, and we also have discussed that what kind of condition gives you a particular solution, right? And we have solved I think one or two questions. So in this session we are going to solve some more questions of GATE previous year questions based on non-homogeneous system of linear equation. But before that, let's just do a quick revision of division of like how non-homogeneous system of linear equation gets divided into three different type of solution. So let's discuss. So we have seen that we can write down the matrix in the form of Ax is equals to b, system of linear equation in the form of Ax equals to b, and if this right side is not equals to 0, then we call it as non-homogeneous system of linear equation. Right? And we have said that it has three types of solution. And what are those? Unique solution, infinitely many solution, and then we have no solution as well. Now one more thing we have discussed, that we will form a augmented matrix, A augmented B, right? We'll write down A and B together and find out an augmented matrix, which we call as A augmented B matrix. So when we'll get a unique solution? When rank of A augmented B is equals to rank of A is equals to number of variables. If I have this condition, then I'll have a unique solution. Then I have said that rank of A augmented B is equals to rank of A but less than number of variables, then I'll have infinitely many solution. Rank of A augmented B equals to rank of A but it is less than number of variable, and then we have said that rank of A augmented B is not equals to rank of A, then we'll have a no solution, because we get one condition that some constant is becoming equals to 0. That would never be possible. And rank of A augmented B equals to rank of A less than number of variable. One more thing we have discussed in infinitely many solution is that free variable concept. How do you get a infinitely many solution? When you have one variable is free. If one variable is free, then you are able to find out infinitely many solution, because you can substitute the values of free variable, like you can take any real number for that free variable, right? So when we have infinitely many solution, it has at least one free variable. And how many free variables I have? How do I got number of variable minus rank of A. So we are going to see questions based on that in today's lecture. Okay, so let's see one by one. So this is a question. Consider the following system of linear equation in three variables, x1, x2, x3. So 2x1 minus x2. I think this we already have solved. If not, then you can solve it by yourself. Right, this is easy. It does not have anything to solve. Let's try this one. Consider the following set of equation, and they are saying x plus 2y is equals to 5, 4x plus 8y equals to 12, 3x plus 6y plus 3z is equals to 15. This set has a unique solution, no solution, infinitely many solution, or finite number of solution. So I told you that there is nothing like we'll have finite number of solution. Only three types of solution exist: unique, no solution, and infinite number of solution. We only have three types of solution. So let's see what three types of solution. Now what would I do? Either I can write down it in a system of linear equation as a matrix 1, 2, 0, 5, 4, 8, 0, 12, and 3, 6, 3, and 15. What would I do? I'll row reduce. R2 tends to R2 minus 4R1. comma R3 tends to R3 minus 3R1. Right, I'll solve it. What would I get? 1, 2, 0. This would be 5 and this would be 0, 0, 0 and 4 5s are 20 minus 8. R3 minus 3R1, 0, 0. 3 3s are 9 minus 9 and this would be 0. I can interchange R3 with R2 to get it in row reduced format. So 1, 2, 0, 5, 0, 0 minus 9 and this would be 0. 0, 0, 0 and this would be minus 8. Now if I'll see here, what is rank of A augmented B? Rank of A augmented B, you would see this whole matrix. Now this whole matrix has 3 non-zero rows. This is non-zero, this is non-zero, this is non-zero. Rank of A augmented B is 3. Rank of A would be, now what would you do? You would just not see this column. This last column you would not look at and you would see only 3 cross 3 matrix. So you can see that how many non-zero rows I have? I have 2 non-zero rows. So rank of A augmented B is 3, rank of A is 2 and they are not equal. I can say that rank of A augmented B is not equals to rank of A. So I'll say that it has the set of equation. This set of equation has no solution. No solution. But instead of doing all these things, I told you that when I have 2 variables, when I'll start with 2 variables, I do not need to have row reduction process, because you can see that these 2 equations I have here have 2 variables. So if I'll solve it, what would I do? I'll just take x out of here. X would be 5 minus 2y. I'll substitute it here. 4 into 5 minus 2y plus 8y is equals to 12. If I'll solve 20 minus 8y plus 8y is equals to 12. 8y get cancelled. So 20 is equals to 12. It is an impossible condition. It is an impossible condition. So that's why we'll have no solution. We'll have no solution. So instead of doing that, I can just solve it within using 2 equations here. So it's up to me how to solve. We'll get the same solution either by row reduction and for this set of equation. So it's up to me. So I think this concept is clear. Let's try one more question. So this is another question. Say they are saying consider the set system each consisting of m linear equation n variables. I have m number of equations and n number of variables, right? They are saying that if m is less than n, then all such system have a solution. What does it mean? That means number of linear equations are less than number of variables. Then they are saying that all such system have a solution. I need to check that all such system have a solution if m is less than n. So I'll try to make some equations, right? When these type of question comes, when you have to prove or disprove, you try to disprove the statement. And if you are able to do so, you just cancel out. And if you want to, like for disproving, you just need to find out an example which would not follow that statement. If you want to prove that, then you have to write down the whole proof and check that. Or you would find out that if you are able to find out any example for that. If we are able to find out any example, then it would be true. Otherwise, it would not be true. Chalo, let's say if m is less than n, then all such system have a solution. So they are saying that if number of equations are less than number of variables, then all system have a solution. Let's try this one. If I'll take a system, let's say I am taking x plus y. How many? I have to take number of variables more. X plus y plus z is equals to 1 and x plus y plus z is equals to 2. 2 equations, 3 variables. First condition gets satisfied. Let's write down. This is my first statement. This is my second statement. This is my third statement. M is less than n, because in this first part m is 3. M linear equation, sorry. M is 2 and n is 3. M is 2, n is 3. So this m is less than n. Then they are saying that all such system have a solution. If you try to find out the solution here, what you would do? Just subtract first with second. Subtract these two, first minus second. What would you get? 0 is equals to -1, which would be impossible. Which will be impossible. So that means this system does not have a solution. No solution. Instead of solving, like, we get that it does not have a solution. So first statement is incorrect. Because they have said that all systems have a solution. There are systems which have a solution, but this is not the correct statement that all such systems have a solution. That all the systems have a solution. This statement is not correct. Now let's go for second one. If m is greater than 1 n, then none of the system has a solution. They are saying that if number of equations are more than number of variable, none of the system have a solution. Let's see. बनाते हैं, try करते हैं, कुछ भी ले लेते हैं. x plus y is equals to 1 and 2x plus, or let's say x minus y is equals to 3, and take 2x plus 2y is equals to 2. Let's take it. Now if you try to solve it, we have 3 equations, 2 variables. I'll write down here. M is what? M is none of the system has a solution. M is number of linear equation 3, n is 2. Right? Now you have to check that none of the system has a solution. But if you would try to solve here, x plus y is 1, x minus y is 1. Let's try to solve. If you would add these two equations, you would get x 2x is equals to 4. Right? X plus x 2x, y and y get cancelled, 3 plus 1 4. X you would get as 2. X you would get as 2, and if you would substitute 2 back in the equation, y you would get as -1. Right? Y you would get as -1. And if you would satisfy in this equation, 2 into 2 4, 2 into -1 -2, we'll get 2. So this is a solution. But they have said that if number of equations are more than number of variables, then we do not have any solution. So but we get a system which has a solution, so this is not true. Now they are saying that if m is equals to n, then there exists a system which has a solution. Now what they are saying, that there exists a system. See, the difference between first, second and third statement is, in first, second statement they are saying that all such system have a solution, all such system does not have a solution, because we cannot specify that for this all thing कि हमेशा ये true होगा. We cannot say that. But there exists a system. Obviously, na, there exists a system. Just take x plus y is equals to 1 and x minus y is equals to 1. And we know that it has a solution x 2 y my 3 ले लो इसको. Y is equals to -1. X 2 y -1. Right? So this system has a solution. M is 2. M is 2 and n is 2. So this system has a solution. Right? So this system has a solution, and now they are saying that there exists a system which has a solution. Because so any system, you from here you can conclude that if we have any system, it has, no matter whatever the number of equation or number of variables I have, that particular system has either unique solution, finite solution, unique solution, infinitely many solution, or no solution. It can be any possibility. I cannot say that all such system have a solution, all such system does not have a solution. So third is true, because they have said that there exist. Previously they are saying that there all the systems, they are talking about over all the systems possible of that particular order. Right? So which option is true? Only third statement is true. Option C is correct here. So this is a question they have asked in GATE CS 2016. So directly you do not have to solve, but you have to apply the concept of the system of linear equation to solve this question. Now let's try another question. So the following system of linear equation, अच्छा इसको थोड़ा सा चेंज करते हैं, इसमें एक add on करते हैं. I think it would be except 5. The following system of linear equation has a unique solution. We have given a system of linear equation and it has a unique solution. The only possible value for alpha is /r. So I have to find out what are the possible values of alpha if this system has a unique solution. And you can see that in the third equation they have mentioned here, instead of a constant they have mentioned here a value alpha. So what would you do? You would write down the matrix, because we know that to solve system of linear equation I have to row reduce. So I'll do the same thing here as well. So what would I do? I'll start with writing the matrix 1, 1, 2. This would be 1, 1, 2, 3. This would be 2. And 1, 4 alpha. This would be 4. And guys, everyone just pause the video and try to solve it by yourself. Just try to solve it by yourself. Right? Chalo. Everyone will check now. R2 tends to R2 minus R1. And I'll do R3 tends to R3 minus R1 because I am row reducing it. Right? I am row reducing it. So what would I get? I'll get here 1, 1, 2, 1, 0, 1, 1, 1, and it would be 0. 4 minus 1, that would be 3. Alpha minus 2 and 4 minus 1, that would be 3. Right? Now, next step would be I'll make this 3, 0. R2 tends to R2 minus 3 R1. R2 tends to R2 minus 3 R1. So I'll have 1, 1, 2. This is 1. 0, 1, 1, 1. And it would become 0, 0. Alpha minus 5 and 3 minus 3. That would be 0. Now, they are saying that the system of equation has unique solution. Now, for a unique solution, we know one thing. For unique solution, if I need a unique solution, so rank of A augmented B is equals to rank of A is equals to number of variables. Number of variables, and number of variables I have here 3. Now, one thing if you would notice here, if I want this rank is 3, rank of A augmented B I want as 3. So alpha would not equals to 5, because if alpha would become equals to 5, rank of A and rank of A augmented B would become 2. Right? If it would become 2, and then you would have infinitely many solution. Right? So for this case, for the system has a unique solution, the only possible value would be any real number except 5, or I'll say that any value alpha not equals to 5. So which option is correct? Any real number except 5. Option D is correct. It was incomplete previously. You have to write down here except 5. Any real number except 5. We are going to understand the concept of 1 minute. We are going to understand the concept of free variable. Concept of free variable. ठीक है, एक बार उसको देखते हैं, and then we'll move to homogeneous. But first we'll understand the concept of let's try to solve one question. So let's try to solve one question. We have an equation x plus y plus z is equals to 2 and 2x plus 3y plus z is equals to 4, and then we have here 2x plus 2y plus 2z is equals to 4. I need to find out solution. I need to find out solution for this system of linear equation. First I have to identify it has unique solution, infinitely many solution, or no solution, or if what kind of solution. If solution exists, then I have to find out the solution. What would I do? I'll try to row reduce it again. What would I get? 1, 1, 1. This would be 2, 2, 3, 1. This would be 4, 2, 2, 2, 4. I'll row reduce it. R2 tends to R2 minus 2R1 and R3 tends to R3 minus 2R1. Right? So let's solve it. 1, 1, 1. This would be 2, 0. 3 minus 2, 1, minus 1. 4 minus 2, that would be 2. 4 minus 4, that would be 0. Correct calculation? 2, 2, get 3 minus 2, 1 minus 2 minus 1, 4 minus. And this would be 0, 0, 0, 0. It is in row reduced echelon form, right? We reach to row reduced echelon form. Now, the question arises that what would be the solution here? So rank of A augmented B is equals to rank of A is equals to 2 because they have 2 non-zero rows. अगर मैं इसकी बात करूँ, पूरी मैट्रिक्स की बात करूँ, 2 non-zero rows, और अगर मैं A की बात करूँ, it also has 2 non-zero rows, and it is less than number of variables. So I'll have infinitely many solution. अब the question arises that how do I find out this infinitely many solution? We haven't done that, so we are doing it now. So what equation I am left with? X plus y plus z is equals to 2, and the next equation is y minus z is equals to 0. Now one thing you would see that you have non-zero entry at the position of x, you have a non-zero entry at the position of y, where you have zero entry at the position of z. So that means z is your free variable. So free variable would be that particular variable in which you do not have a non-zero entry, right? So this is my free variable. Now z would become free variable. So that means z would be any value k. If it is free variable, you can put any real number. So I am just substituting it k. So z is k, then with the help of this y minus z is equals to 0, you would get y is equals to k. And x plus y plus z is equals to 2. With the help of this, what you would get? You would get x you would write down as it is, y is k, z is k, and this is 2. So x you would get as 2 minus 2k. So your solution x, y, z, this would be the vector which you need to find out. What is it? 2 minus 2k, and this would be k, and this would be k, where k belongs to real number. So it has infinitely many solution because I can replace the values k, and because only one free variable, so we have one constant k. We have one free variable, so we have one constant k. Right, so that's how, if we have infinitely many solution, that's how we find out infinitely many solution. Let's try one more question. ठीक है, इसको डिस्कस करते हैं. Let's try this question. X plus y plus z is equals to 1. 2x plus 2y plus 2z is equals to 2. And then 3x plus 3y plus 3z is equals to 3. I need to find out solution to this system, right? First I have to check the system has a solution or no solution. If it has a solution, then I have to find out that. So let's try to do that. I'll start with, I'll start again with row reducing the matrix 1 1 1, and the right side would be 1 2 2 2 2 3 3 3 3. Right, so what would I do? R2 tends to R2 minus 2R1, and R3 tends to R3 minus 3R1. Right, so what would be the matrix? 1 1 1 remain as it is. It would become 0 0 0. This would be 0 0 0 0 0. So this is in row reduced recurrent form. I got this matrix as a row reduced format. Now if I'll check here, what is rank of A augmented B? Rank of A augmented B is 1. And if I'll check rank of A, just you do not use this column, and with these three columns, rank of A is also 1. So it has a solution, but it is less than number of variables. Number of variables I have 3. Number of variables I have 3. So rank of A augmented B equals to rank of A. So I'll have here infinitely many solution. Infinitely many solution. Up the last one and this one is little bit different. Do you remember we have discussed at the start, when I have started all the concepts, I have said that, what I have said, that rank of A augmented B, rank of A is less than number of variable, that gives me my infinitely many solution. But one point I have said here, that free variable is equals to number of variable minus rank of A. How many variables I have and whatever the rank I got, I'll subtract that many free variables I have in my system if I'm getting infinitely many solution, right? So you can see here, when I have solved this when I have solved this system, rank here is 2. Rank I got as 2. Rank of A is 2. Variables I have 3. So 3 minus 2. So number of free variables I got here. Free variables I got in the previous question was number of variable. In total variable कितने हैं? Minus rank of A. Number of variable 3 minus 2. That would be 1. Or I can say that the position at which we do not have a pivot entry. For X I have a pivot entry, for Y I have a pivot entry, but for Z I do not have that, right? I do not have here. So what would I do now? Now you can see that in this matrix, sorry, galat question pe aa gaye. Now we have a pivot entry here. We have a pivot entry here, but not here and not here. It is a non-zero value. We have a 0 value at the position of Y and Z. So either I can say that directly Y and Z are free variable, or I can find out by free variable definition. Free variable is number of variable minus rank of A. How many variables I have? 3. Rank of A is 1. So number of free variable I have 2. And also here I can also check that directly that I have 2 free variables. Y and Z are my free variable. Let's say I'll take Y as K1 and Z as K2. Right? The last equation I have here is, if these are free variables, I can take it any value. I can either take it K1, I can either take it K2. I have my choice. So K1 K2 भी मैं कुछ भी लिख सकती हूँ. So X plus Y plus Z is equals to 1. What would you write down? X plus K1 plus K2 is equals to 1. So what would be the value of X? 1 minus K1 minus K2. So the solution would look like X, Y, Z. The solution would look like 1 minus K1 minus K2 and K1 K2. So that's how you find out system of solution of infinite system of linear equation if it has infinitely many solution. Either one more type, you can write down the solution. Let's suppose if it is not written in this format, you haven't taken y k1 and z k2, तुमको y को y रहने दो क्योंकि y free variable है. Just remember that y and z are free variable, right? So x would become from here 1 minus y minus z. So sometimes the solution can be written in this format as well. So I can write down 1 minus y minus z, y and z, instead of writing k1 k2. So they would say that y and z are free variables, so you can, so this type of solution you can also get. You can get that we have a solution of this kind, right? So that's how we are going to solve system of linear equation, right? Infinite, if we have infinitely many solutions. So we have seen that now if I have 2 variable, then I'll go for simply substituting or elimination. Otherwise, if I have 3 variable, it gets removed. 2x plus 2y plus 2z equals to 2. This is y. ठीक है, वो थोड़ा erase हो गया, right? So what I was saying, that if it has 2 variables, then you can either go for substitution or elimination. But if it has more than 2 variable, you are going to solve using matrices, and using this method you would get to know this one, that either you have unique solution, infinitely many solution, and no solution. And we have solved question based on no solution, unique solution, and infinite solution. We have solved all 3 types of solution. And one more thing you have to understand is free variable. Free variable concept is important because we are going to use this free variable concept in homogeneous system of linear equation as well. So you would understand that. So in next class we are going to discuss homogeneous system of linear equation, in which we are going to talk about Ax equals to 0 solutions, right? What kind of solution this Ax equals to 0 has, and when we have that particular solution, we are going to discuss that as well. And we are also going to discuss gate questions based on that. And also one more thing, those gate questions, like mainly you would see that majority of questions they have asked from homogeneous system of linear equation, which we are going to discuss it tomorrow. So make sure guys, till this point everything is clear to go for homogeneous system of linear equation. Okay, so yeah, that's all for this video guys. If you have any question, you can just let us know in the chat section. I'll be happy to help you. Thank you for joining.